Hi, I'm Betty McCracken. I work for the Monacan Soil and Water Conservation District as a conservation specialist. Today's topic is groundwater. I have brought my groundwater model here for you to see. Groundwater is very important to human beings. Even though 71% of our planet is water, only 1% of that water is fresh water. And of that 1% of water, 80% is locked up in the glaciers in the North and the South Pole. Many of us have wells in central Virginia. And we're interested in having fresh water and clean water coming out of the ground into our homes. Groundwater also helps our rivers stay high. It is a source of water for our ponds and our lakes and our reservoirs when it's not raining. You see that those typically stay full because of the groundwater recharge. So there's water going in the model here. I want the water to be running through the model for my demonstration, so I'm going to release or discharge the water right here. You can see the water going down. Here is the top of the water in the model right here. The top of the water in the ground is called the water table. And so we are very interested in the water table. Our precipitation charges up the groundwater system, and when we have a lot of precipitation, the groundwater and the water table is very high. And when we have times of drought, then the water table goes down lower. The water is actually moving through the model because of gravity. Gravity is pulling the water from high to low, and the water is able to move through the pore spaces. The larger the stone, the bigger the pore space, the quicker that water can move through there. And I will give you an example of that. So I'm going to put water in this observation well right here. It's down here in the bottom. See there? It's gone below the confining layer. So it's going to be stuck in these rocks here. Watch how fast this color moves through these bigger pebbles. The bigger pebbles have bigger spaces, so the water moves faster that way. I'm also going to put some water in our point source. We're going to pretend like this is at my house and my septic tank is leaking. So we're going to put this blue water down in the point source pollution area. And if my septic tank is leaking, all that water that's leaving my house is going underground, and some of it can bubble up to the surface just like it's showing, but that blue water is not staying where it's supposed to stay, and it's moving, isn't it? Remember how the gravity is pulling the water through the model? This is happening under our feet in Virginia too. We have mountains in our west, and we have sea level, we have the Chesapeake Bay, and we have the ocean to the east in Virginia, and water is moving under our feet from high elevation to low elevation all the time. Look how quickly that blue water has moved. This is polluted water, remember? This was what we indicated was going to be our polluted water from our septic system. It's moving into the lake. That's gross. We don't want polluted water in our lakes, do we? And if you'll notice, it's moved. Here is a well right there. Let's say that's my neighbor's well. We're going to pull water out of the well, and we're using it to cook our string beans and to drink and to wash our clothes. And there is blue water coming out of that well, and that's coming from my septic tank that is polluting underground. When you think it's gone, it's not really gone, is it? It can still get in the groundwater system. So we as human beings affect our environment in many ways. And you can see the blue water that I pulled out of the well, and that would be going into somebody's home. There is food coloring coming up into the lake over here. How did it get there? I did not put it there. but you saw when I injected the red food coloring over here in this injection well here, it went below the confining layer, which is the clay. The clay is tightly packed. The red dye moved very quickly through the pebbles, and there's a little pipe that you can see, maybe a little part of it right there, and it is bringing up that water from this confining layer. It's called an artesian well. This is Betty McCracken. I hope you learned a little bit from this groundwater demonstration. Thank you.